We are now in 8.5, which is annuities, methods of savings, and investment. So here are the concepts we are going to learn about. So let's recall a few concepts. Rounding. So here is our place value chart. Round to the nearest 10. So we're rounding. There's the 10th place. So we got to look at the ones place to determine if we're going to let it stay the same or round up. And this one's going to stay the same. This next one, round to the nearest 10 again. So the 6 is going to make the 7 go to 80. So if it says 10, we're talking about above or to the left of the decimal. If it's tenths with the THS, we are going behind the decimal. I recall dividing 1 divided by 0.3. 1 divided by 0.3 is 3.3 repeating, or 3 1/3. Right as a decimal, we have percent to decimal, so DP. So decimal to percent, you go right. Percent to decimal, you go left. And you're always going 2 spaces. So we're going from a percent to a decimal. So we're going to move it over 1, 2. Put a 0 in that place. So 0.004 is our decimal. Let's talk about what an annuity is. An annuity is a sequence of equal payments made at equal time periods. The value is the sum of all deposits plus the interest paid. So you are earning interest off of an annuity. So here is a formula to find out the amount of money that is in the account or in the annuity after T years. So P is the deposit made at the end of each year. We're paying annual interest. Make sure to write your R in decimal form. And this is compounded once a year. So the value A after T years. So we're going to use this formula anytime it is compounded once a year and deposits are made at the end of each year. So here is an example. Suppose that you're 35, you decide to save for a retirement, depositing $1,000 into an IRA at the end of each year for 30 years. If you count on an interest rate of 10% per year compounded annually, how much will you have in your IRA after 30 years? So A equals, it says P, the deposit made at the end of each year. So that's the $1,000. And then I need to do bracket, parentheses, 1 plus the rate. So I need to move the decimal over 1, 2. So 0.10. You can leave off the 0. And then raised to T, which is 30 years, minus 1. Close that. And it's all over the rate, 0.10. So I'm getting this directly from this formula. I'm just substituting it. Okay, we can use our calculator for this. If you don't have a calculator like this one, you might need to do things individually. So you might need to do this and then multiply by 1,000 and then divide by 0.10. But since I have this calculator, I'm going to use the fraction function. I'm going to use parentheses instead of brackets. So it's kind of like a double parentheses there. Close parentheses and then divide by the rate. Make sure after you use the exponent, you arrow to the right so you can get down from that. Okay, so 164,494. We're going to round to the whole number. I'll put a comma there. So $164,494. If you deposit $1,000 into your IRA for 30 years. All right, we have a different formula. If it's compounded in times per year, and when you are depositing, if your deposit is made at the end of each compounding period. So let's say you compound monthly. So then N would be 12. Okay, so it's very similar to this one. The only thing is anytime you have a rate, you're going to divide by N. And anytime you have time, you're going to multiply it by N. Let's look at the example. Oh, here is, yeah, let's go to this example first. All right, so it says $30 at the end of each month, 6% compounded monthly, and we have 30 years. So T is 30. The rate is 12.06. $30 is how much is being put in. And it says 30 years, compounded monthly. So N is 12 when it's compounded monthly. So let's plug it into that formula. So I'm going to pull up this formula again. All right, so A equals P, so the $30, 1 plus the rate, 0.06, over N. Oh, I forgot to do parentheses there, and then N times T, 30, and then all minus 1, close your parentheses or do a bracket, over the rate, 0.06, over 12. Okay, so we can put this in our calculator. 30, 1 plus, okay, so that's our numerator. And our denominator, oh, I need to go to, I accidentally put enter before I was ready. Okay, so the annuity will have $30,135. So that is part A. Use the appropriate formula to find the value of the annuity. So that's part A. Part B is to find the interest. So in order to find the interest, we need to find out how much was total deposited and then take that away from how much the annuity is. So to find out deposits, that's found by multiplying how much money it is. So our principal, $30, 12 times a year, and 30 years. So I did principal times how much is compounded times the time. So 30 times 12 times 30. 10,800 was deposited. And so to find the interest, you would find the difference between these. The annuity minus deposits is going to give you the interest. So 30,135 minus 10,800. $19,335. That's how much interest was earned. Pretty good. Okay, let's go back over here. Regular payments needed to achieve a financial goal. So the deposit P that must be made at the end of each compounding period into an annuity that pays an annual interest rate compounded N times per year. Here is our formula. So this is going the opposite way. We want to find out what the deposit needs to be made in order to have a certain amount of money at the end of so many years. So let's say you want to have $1 million after 35 years. How much money do you need to put in each month? So that is our formula. So let's look at this example. Go ahead and read over it. Okay, so A is how much you want in your annuity, 20,000 after 5 years. End of month deposit, so N is 12. And our rate is 12.06. So once we have all of our values, we can plug it into the formula. So how much should you deposit each month? So we're going to plug it into this formula. So 20,000. The rate, 0.06 divided by N. And then let's do the denominator. So once you have it written, you can put it in your calculator. So I'm just working on putting these in. Okay, 286.65. We're going to round to the whole number though, or 96. So I'm going to say 287. That way it gives you a little cushion. Because if you do 286, that won't be right. All right. So we found out how much money should be deposited. So now we want to find out part B, which says how much of the 20,000 down payment comes from deposits and how much comes from interest. So we know it's going to be 20,000 total. So we need to find out how many total deposits. So you're going to do the 287, how much the payments are, times 12 months times 5 years. So that was the P times N times T. So 17,220 is how much deposits were made. So to find out interest, you're going to take the 20,000 that you have in your account and subtract the deposits. $2,780 is how much interest. Okay, you can go ahead and read over investments, stocks. So you can pause it while you read. Okay, bonds, you can go ahead and read about that. Pause it if you need to. One thing that I do want to highlight is financial advisors recommend a mixture of low and high risk, and that's called diversified. That way you don't put all your eggs in one basket. All right, let's look at how to read stock tables. So we have company name right here, and then its symbol. The closing price is right there. And then let's look over here. Then we have open price, the high of the day, the low of the day. And this gives you the net change from the day before. So this was July 9th. And so that tells you that the day before it was lower than this by $1.87. And the stock table also gives you 52-week high, which would be for the year, and 52-week low, which are right here and here. And then volume refers to the number of shares traded on that particular day, and it's in millions, so this is in millions. And then average volume is the usual amount, so the average over a fixed period of time. And then market cap refers to the total value of all the company's share of stocks, given here in trillions. Wow, that's crazy. But you see right here, 2.42 trillion. And then PE, right here, stands for price to earning ratio. And it's found by doing closing price over annual earnings per share. You will be asked to find annual earnings using closing price and P&E ratio. So we're going to do an example, reading stock tables for Amazon. So I have some questions over here. What was the closing price on July 9th? So this is our closing price. B, what was the closing price up or down from the previous trading day? So this little arrow down, and it would be in red, tells you that it's down. On the previous one, it was green and it's up. So closing price, it was down. And by how much? $12.07 or 0.32%. What was the closing price on the previous day? So what you're going to do is you're going to look at today's closing and either add or subtract. So it says that it's down, so that means I need to add. Because this is my current, so the previous day was more by 1207 because today it's down. So that comes up to 3,731.41. What was the high and low price? Well, high and low were right here. So high was 3,748, and then our low was 3,693.40. Party. What were the high and low prices for the past 52 weeks? So you look at 52-week high, 52-week low, and write those. It comes directly from there. How many shares were traded on July 9th? So that's your volume, 3.75 million. And was this above or below? So you look at average. The average was 3.4 million, so it's above. Above average. What is the total value of the stock? So you look at market cap, so 1.88 trillion. And then the last question is about annual earnings per share. So you find that by doing your closing price per share and divide by the P&E. And when you divide that, you get 52.38. You can go ahead and read the last two slides talking about retirement, savings, taxing, and all of that.